visual artist, as whatever, as a scientist, any of these things, where you can't go too far or nobody will follow you, but you can't stay too close to the known or nobody will be inspired by that. So there's this interesting place where people have to be.
There's a great documentary, one of my favorite documentaries of all time is called 𝕝𝕚𝕧𝕖, and it's about the great comic artist from this underground comic artist from the 60s and 70s, Art 𝕝𝕚𝕧𝕖, and it follows, anyone listening should watch it because it's one of my favorite documentaries, and the point of the documentary is to follow 𝕝𝕚𝕧𝕖, but then the documentary veers off and visits. He has two brothers, and the documentary spends time with both the brothers. Both are very clearly mentally ill and can't really function in society. And you see that they're just, one is a click to the right of 𝕝𝕚𝕧𝕖 and one is a click to the left. And so they can't be in society, they can't really live normal lives. They're very profoundly strange people. One of them has a very sad ending. And then there's 𝕝𝕚𝕧𝕖, who, as you said, David, is just, he's hit the sweet spot where it's very strange, it's really weird, but it is just right, and he becomes famous. So to me, that is the best description of what we're talking about here, that controlled schizophrenia.
Yes, that is a fascinating documentary because it's the Goldilocks spot of artistic potential, isn't it? Because you see it in both the others have all this potential, but it's kind of just too far. It's amazing.
We're talking about, we kind of jumped in the middle talking about the immense complexity of this, as we call it now, a 3-pound blob of stuff in your head. Can we go back? What do we know about how it comes to be, how it develops? I mean, we have 20,000, 25,000 genes. There's not a lot of, seems, genetic code in there. But somehow, from an embryo through to an adult, this thing becomes the most complex thing we know of in the universe. So could you outline, perhaps, David, start, what we know about that development process?
Yeah, this is the topic of my next book, which comes out soon, called Live Wired. And the argument is that you've got, about 19,000 genes, which set things up in an extremely sophisticated way. But from there, Mother Nature's great trick was to drop a human brain into the world, essentially half-baked. And then we allow our environments to wire up the rest of it. So your local language, your local culture, your belief system, all that stuff you absorb. This is different than many other animals. Like, if you're a Komodo dragon in Indonesia, you get airlifted to Canada, to snowy Canada, you're not gonna live. But humans, in contrast, have taken over every spot on the globe because we're so flexible, we're so flexibly intelligent. And again, this is because of nature's trick of saying, look, I'm not gonna make the whole clock, I'm just gonna make it so that it absorbs the world around it and learns what's going on.
Gina?
Yeah, I mean, I think what's also really interesting is that in the 21st century, we're now much more aware of how aware babies are. So there was this idea that we've got this kind of brain which arrived almost like a smartphone with preloaded apps, and it kind of developed along set lines. And babies early on, because they were so helpless, human babies, were kind of dismissed as subcortical and their frontal lobes were silent. But we now know that human babies are amazingly responsive to what's going on around them. And they're picking up clues from the moment of birth, if not before. And I think that's a fantastic insight into how much the world will impact on this 3-pound blob of stuff.
And so the brain is becoming more and more structurally complex, physically complex, in response to the stimulus.
It's the exact detailed wiring that becomes more complex. And just as Gina said, one of the things that we've really come to understand is the importance of all that input when one is an infant and a young child, because there are these tragic cases of feral children who, because of mentally ill and abusive parents, didn't give the child love and speech and all these things, but instead locked them in a closet, that sort of thing. And these kids are very mentally damaged. You can actually see this in Romanian orphanages. After Ceausescu, there were tens of thousands of Romanian kids who ended up in orphanages, and because there were too many kids, the staff decided they wouldn't hold them or talk to them. and these kids ended up really damaged in terms of IQ, in terms of capacity. So it's an interesting gamble that Mother Nature takes, because she relies on having the normal sort of input from day one.
Can I ask, in the book, there's two interesting cases. The first one is you talk about a 3-year-old called Matthew, who has, I think it's his right hemisphere removed due to seizures.
That's exactly
and
right.
it seems that, so he has basically half of his brain removed at 3 years old.
Yeah,
But
exactly.
can you just run us through what happens then, the development that you then see?
Yeah, I mean, the
Child
remarkable, so
disorder,
this is called a hemispherectomy, where you take out a whole hemisphere, and remarkably, if you do this in a child under the age of 8 years
Tylenol?
old, they're
We
fine.
don't have any.
They often have a slight limp on the
Tylenol?
other side of their body, but otherwise cognitively they're completely fine, because the brain says, oh, I only have half the real estate, that's cool, I'm going to rewire all the functions on the remaining half. And so we have all of these
I'm
experiments.
testing
Sometimes you have
right
children who are only
now,
born
seeing
with
if
one
I-
hemisphere.
You won't be.
And
just
you know, again, they seem perfectly fine. And when you
No,
do
I'm not
neuroimaging
testing
on them, you
just
find
the
that
sound.
the functions of the missing hemisphere have essentially just ported themselves over.
See, that seems surprising to me, Gina, because you would think, I kind of assume that evolution is not profligate, right? It doesn't give you twice the size. There are all sorts of problems, aren't there, with the fact the human brain is rather large. So how can it be then that you can adapt to having only half the mass? Would it not be better because I would have smaller heads? In that case, it seems to be, you know,
Keep in mind,
if I were designing.
keep in mind, Brian, we're symmetric around the central axis, so you also have 2 arms, 2 legs, and 2 eyes.
Yeah. I mean, I think, in fact, there's a kind of misunderstanding about brain plasticity. In fact, when people keep thinking that if your brain is plastic, it gets bigger when you learn something. And there's this kind of image, just to show my age probably, I don't know if you remember 𝕝𝕚𝕧𝕖 comics, when there was the Nikon, which you had this huge brain. It was the idea that human beings, why haven't we got a huge brain? Because we're much cleverer than other people. So there is a point at which the brain starts to become more economical, and to reuse real estate. And you get that extremely with children, very small children. And it was always assumed that past the age of about 10, because we had this idea that we're born with the adult number of brain cells and they don't replace, that we've got this kind of hardwired brain, which once it's grown, that's it, and that's the brain that's going to carry you through to old age when you fall off the cognitive cliff. But one of the things we now know, which David has written about as well, is that the brain remains plastic throughout our lives, not getting bigger and bigger as we learn things, or smaller and smaller as we forget them. Although to some extent there is an element of that. So that's something that's really interesting about the brain, about the fact that the brain is constantly adapting, and that could well be the secret of what we call the human race's success, although they're pretty good at making failures of quite interesting things.
It would be very useful, in my opinion, if the brain did get larger the more intelligent you were, so that we could easily identify who was intelligent and who was not. And I would find that, I am 100% Irish, so a lot of us have very large heads, but not a lot of intelligence, and it would be it's very confusing. It's very confusing.
There's a Simpsons cartoon of Homer Simpson with a tiny little brain inside a big head, so having a big head doesn't necessarily mean you've got a big brain.
One of my favorite jokes when I was working at The Simpsons, this is not a joke I wrote, but I was in the room when we came up with this, was Homer is doing something he shouldn't be doing. I think he's on his way, or he's just stolen some liquor, or he's about to go and steal. He's about to do a bad thing that I think has something to do with alcohol or beer. And so a policeman says, "Where are you going, Mr. Simpson?" And there's a quick tightening shot of quick zoom in of Homer's head. And his brain says to him, "Homer, come up with a good lie." And then you zoom out, and Homer says, "Officer, I'm off to buy pornography." Then, this is the interesting part, the camera zooms back in tightly on Homer's head, and his brain says, "That's it, I'm out of here," and you hear footsteps and a door slam. So, in the room, we wrote this joke, and then we started debating, wait a minute, we just made Homer so stupid that his brain walked out on him. And yeah, and I've been thinking about it ever since, that I often, I'll be annoying my children, and then I will say to them, you know, being silly around the house and annoying them, and then I'll suddenly jump in and say, don't let him worry you. He's just that way today. And they'll say, who? And I'll say, Conan. And they'll say, no, you're Conan. And I love to get outside my head and blame my brain on something that I have just done and act like the innocent bystander. And I find that very effective. You can easily do that with people and it throws them off.
Yeah. You can go back to the idea that bigger is better. That was the kind of origin of brain science right from the beginning. And you know, just to casually introduce a concept about sex differences in the brain, it used to be thought that men were better, had superior brains because they were bigger. And that actually still very much informs what we think about the brain. So people come up with papers saying, oh, you know, so-and-so's got a bigger amygdala, or men have got a bigger amygdala, or women have got a thicker cortex. So the whole size matters thing, characteristically in this sort of debate, is something which has informed a lot of brain science.
Yeah.
Is it right though the disparity between male and female brain size is pretty much in conjunction with actually the disparity in size of,
Yes.
of men and women? So it's basically equal.
Yes, that's right. So if you correct for the fact that male brains from men are about 10% bigger than brains from women, men are about 10% bigger than women. So and if you correct for that, the differences pretty much disappear.
I wonder why all those male scientists didn't want to. It's weird, isn't it, when they do? It's quite a simple calculation, isn't it?
If they'd come up with the idea when they first started looking at male-female brains, if it turned out that male brains had been smaller, you'd have bet there'd have been a big argument about streamlining and economy and, you know, and etc.
You know, in the 19th century, there was a huge, 18th and 19th century, people were obsessed with great men having bigger brains, and you saw this a lot actually in the Soviet Union, where it was very important that they report that Lenin had an abnormally sized brain, or that Stalin had a very large brain after they had died, when a lot of the times it wasn't true, or we've learned since it doesn't matter. And there was a real, when Lincoln was killed at the end of the Civil War, they did an autopsy and they removed his brain, and they were stunned that it seemed normal. They just couldn't comprehend how could such a great man have a normal-sized brain, and so that idea persisted for a long time. I think it's fairly recently in history that people have thought, wait a minute, that has nothing to do with it. Size has absolutely no correlation at all.
So I just wanted to go 1 second tangent, return something Conan said about that Homer joke, because this is really the interesting thing about the brain, and this is what I said in we were asked to introduce what is weird about our brains. You know, the fact that we're made up of a team of rivals, speaking of Lincoln, you know, this idea that you can argue with yourself and cuss at yourself and cajole and so on, or that part of your brain says, come up with a lie, and then you do, and then part of your brain says, that was really stupid, then a different part of your brain says, actually, maybe that wasn't so bad, and so on. This is the interesting thing about why humans are so complex and nuanced, is that we are not one thing, the way we think about building artificial intelligence with a single mind. We're instead essentially a whole bunch of minds all packed in there that are always vying for power. It's essentially like a neural parliament where, based on the vote, at any one moment, maybe you'll eat the cookie or you won't eat the cookie, or you'll eat the cookie, but you'll contract with yourself to go to the gym later or whatever. But this is the complexity of being a human. There's all these different votes going on all the time.
Well, that's because another thing that reminded me of talking about Homer's brain leaving was that there's a lovely line by the late theatrical impresario Ken Campbell, who once said, "Me is just one of the things my brain does." And I think that sense of the mind, because that also comes into it to me, that there's all this hardware, but a lot of this hardware isn't me, is it? If you see what I mean, that's when we're talking about that sense of personality and development, the mind and the brain, that's something that is rarer in animals, isn't it? Generally, mind to have a mind and a brain.
Well, exactly. I mean, this was actually my book 𝕝𝕚𝕧𝕖 was about all the stuff happening under the hood, which is almost all of it. You know, you don't have access to or awareness of the huge majority of what's going on in your brain that allows you to walk and talk and eat and everything else that's going on and run your body and so on. And even the things that we think of as traits of our personality, you know, these just pop out. We don't intend to do these or choose to do these. This, of course, has led to this very deep question about, do we have free will at all, or is the whole thing a machine that's running? It certainly seems to be that it is a giant machine. If we learn in 100 years that there's something we hadn't realized yet that does save the notion of free will, what's clear is that if free will exists at all, it is a bit player. It is the smallest bit of what's happening in the brain. Maybe we would say free will is just one of the things that my brain does, and the smallest part.
One of the things that you brought up, Robin, was this idea that me is just part of what my brain does. I think we've all had that experience. I've had it a lot, where you're driving on a long trip, and you're driving and driving and driving, and you're on a highway, you're on an interstate, and you suddenly realize that you haven't really been conscious for about an hour. You've been driving, you've been making turns, you've been making decisions, but you really haven't been there. You've been daydreaming. I don't know if any of you have had that. I've had that, and then I found out later that I've killed many people. But I am aware that something else has taken over. My brain has said, I can handle this, and then I start thinking about other things, and I'm navigating turns, I'm taking care of business, but I don't really feel that I am driving the car. Is that something you've all experienced, I hope?
See, Gina, that is one of the, I mean, that when something like that happens, it does appear that there is a case to say, you are not required. This unconscious functioning, we'll get on with, we are this kind of post hoc rationalisation, which is kind of scary.
Yeah, and you can track that too. If you give somebody a difficult task to learn, you can see the kind of whole brain gets involved, and then as it gets more automatic, then less and less of the brain is involved, and it kind of even the areas of activation shift in the brain. So it gets stored away as a kind of, you know, this is the driving along the highway, whatever. I don't need to pay attention. Luckily, mainly, if something, you know, somebody steps out in front of the car and you're not in a Tesla automatic car or whatever it is, self-driving car, your brain will respond quick enough to switch off from automatic and avoid the person. But yeah, I mean, I think the idea is a lot of what we do, we pay no, you know, we don't know. If we did know what our brain was doing all the time, then maybe we'd be schizophrenic. You know, there is the idea that sometimes what's coming through is the brain hasn't managed to shut down enough of the processing, which is going on all the time. So we have these kind of delusions, which we then, you know, because we try and make sense. Our brains are trying to make sense of the world around us. So if we think there's a voice coming out of the television, we will make sense of that and saying somebody's listening to my thoughts, for example.
Yeah, we talked earlier about this, I suppose it's the central, the hardest question, the nature of the self. I wonder whether, in terms of the location of the self and the structure of the brain, there are obviously bits of the brain that deal with different things, physical processes and so on. Are we any closer to being able to identify the position, the location?
No, I mean, it's not that we're not closer, it's that there is no central location. And we know this because people have gotten brain damage over the centuries, and there's no brain damage where sort of everything else is running fine, but you've lost yourself. It's a distributed process. It would be like if you looked at the city of New York and you said, okay, where is the economy of the city? It's not any one place, it's an emergent property of the functioning of everyone interacting there.
Is it, Gina, is this because David said that every time I talk to neuroscientists, actually, if I say emergent property, they just laugh at me. But it's something, it's kind of glossing over some, or am I talking to the wrong, I'm hanging out with the wrong neuroscientist?
Sometimes because you haven't got a nice neat answer, you say, well, identity isn't there. I mean, you could put somebody in a scanner and give them a list of words and say, which of these words best describes you, which of these words best describes your best friend, or which of these words best describes President Trump, for example. And you would show different areas of activation. So then people would say, oh look, the bit of your brain which is activated when you're thinking about words that best describe you, that's where the identity is. So there's this kind of still this whole idea that there's a bit in the brain that does identity. It's what I call, the God spot or the chocolate spot. Early on with brain imaging, people were still trying to do like the phrenology thing and putting the brain into nice little boxes and saying, that's where justice is, or maternal instinct or something.
I love the comparison of, you've got a choice, God or chocolate.
Yeah.
Richard Dawkins has had all the chocolates already. It's too late.
You'd be very interested to know what areas of the brain are activated when people are thinking about chocolate, actually.
Right, I just want to jump in and say that the notion of emergent properties is it's necessarily a well-accepted notion, because if you look at a neuron, you don't have anything about your identity or consciousness or something in a neuron. It's something that you have to put together 86 billion neurons to get out of it. And so I've actually never heard a serious neuroscientist disagree with the notion of emergent
No,
properties.
me neither.
Oh, I just was curious if the goal in life, or if you could say a goal for many people in their lives is to live to the fullest. What we're talking about here now lends me to believe that we need to be challenging ourselves radically every day, so that our brain is constantly having to shake things up. That any kind of routine that a lot of people would look at as very zen, meaning I do a little gardening, then I go and I get a croissant, and then I look out the window, and then I go birding, and then I do a little bit of my work, and then I take a nap, and I do the same thing every day, is putting yourself to sleep. Whereas we should be challenging each other. I should try and heliski tomorrow, and then the next day I should buy a rifle, and I should try and kill an eagle, and then I should try and fight a tiger. Like every day, so that however long my life lives, I've lived. My brain has had to reorganize itself. If I have 8,000 days to live or whatever, that means I've had to reorganize it 8,000 times. Is that what I'm describing is insanity?
Yeah.
But maybe that is.
Yeah.
That's what I love. We started with your dad's psychiatric diagnosis of you, and in 3 days' time we read in Variety, Conan O'Brien kills an eagle while heliskiing. That is a beautiful narrative arc created there.
Yeah, but then then I would have a completely replasticized, reorganized brain, and I could come on the show again in a week, and I'm holding the head of an eagle, and you say, what are you up to now? And I say, well, I'm going to go put on some Flemish armor, and I'm going to jump in the ocean and fight a squid. And you're going to say, wow. And then I come on the show again. So I keep reorganizing myself. Is that possible?
Yeah. If you came via a brain scanner each time, that would be really interesting.
Yeah.
But your intuition is exactly right, Tony. And part of this came out of, there's been a study going on for about 30 years with nuns who live in a convent, and they've agreed to donate their brains upon dying. And what the researchers discovered over the years is that a fraction of these nuns had Alzheimer's disease, but nobody knew it when they were alive. They didn't show the cognitive deficits that are typical of it. And it's because they were challenged every day. They had, social life and chores, they were playing games, and they dealt with each other. And this is in contrast to people who retire and their lives shrink, and they no longer are challenging themselves. So it was exactly because of this everyday being novel and challenging that they were building new pathways in the brain. So even as it was physically degenerating, they were finding new connections. So that's exactly right.
I mean, I think that you
Don't let the
hesitate to
parents
stray into the area of brain
get
training,
lazy.
but certainly there's a suggestion that to prevent the cognitive decline that goes with aging, you could learn to kill an eagle or heliski or tango. That's very good apparently, or a second language. The latter two may be safer than the other two, so you may live longer to test the theory.
I think there needs to be an element I honestly believe there needs to be an element of fighting a creature in the wild to really spur the brain.
Yeah, he's always
Tango
trying
will
to
very
kill.
quickly become just another lesson you're
So
doing
not
and a glass of
environmental.
wine afterwards. But fighting an animal, a wild animal, I think is the best way. And I'm seriously suggesting this to everyone out there to maintain and increase life plasticity.
Yeah, the key is only to do it until you get good at it. As soon as you get good at it, you switch to something
Yeah,
else.
move
Yes,
on, yeah.
yes, before it becomes too mundane. Yes. As fighting wild animals, let me tell you, eventually becomes mundane.
Talking about the plasticity of the brain and development with age, I mean, you worked in the writers' rooms of things like, Saturday Night Live, and from what I can gather, a lot of the big shows in the US, kind of people are reaped from the major universities, they go into the writing room, and they're kind of just wrung out, and then almost by maybe even your late 20s, you may well be spent. And is that true for a lot of the kind of the comedy writing process?
I think it's particularly true at Saturday Night Live. Saturday Night Live, of all the different shows I've worked on, The Simpsons, for example, is very collaborative. You're all working together, and if you think about it, you're dealing with these characters that have essentially been around since 1990 or the late 80s, and so you're playing all on a level field, and it can feel very civilized. The hours are long, and the food is bad, but it's a very civilized way to live. Saturday Night Live is very much, there's a limited amount of time on the show, and there's a lot of writers, and to get something on the show can feel like a gladiatorial process, like you're all having to fight it out, and you're sleep deprived, you stay up for, and I think this is, I'm not even kidding, I think this is a holdover from the 70s, when writers did a lot of cocaine and stayed up. My generation of writers didn't do anything like that. We just monitored our cholesterol, and we were, and tried to maintain a good body mass index. That's my generation of writers. But we inherited this system where you stay up. The host comes in, and let's say it's Eric Idle's the host, and you meet with him on Monday night. And then you stay up all day Tuesday, all through Tuesday night, and all into Wednesday, and you don't sleep until Wednesday night. And you torture yourself, and then you find out, did you get something on or not? So I did a couple of seasons on Saturday Night Live, and I thought, if I don't get out of here, I still have PTSD, and as wonderful as an experience as it was, and I'm not even kidding, but I have a form of PTSD from my time at Saturday Night Live. So yes, very much so. I was in my 20s. It's very much being a fighter pilot. You feel like you've pushed your neurons to the max. And I went from there to The Simpsons and realized The Simpsons was a far more civilized way of writing comedy. Saturday Night Live is very much the equivalent of running a marathon while fighting wild animals. That's what it felt like to me.
Let's go to something we discussed, both Gina and David. It's something we discussed earlier about the complexity of the brain and this idea that this tremendous experience of the world emerges from this structure. We're obviously a long way from understanding what that structure is. There's a Human Brain Project, of course, which is the European project, which is attempting to get there at some level at some point in the future. But maybe I should start with you, Gina. How close are we, or can you even envisage a time when we will have an understanding of how this structure delivers this experience of the world?
Well, there's a phrase which I'm sure David's familiar with, that if we were, if our brain was so simple that we could understand it, we'd be too simple to understand it. And I think that kind of sums up, being a neuroscientist. We're in the foothills of understanding the brain, and with new technology, we may have better ways of dealing with the data. We might have more insight. But as soon as something emerges, there's another kind of chemical interaction discovered, and then the brain is fascinating. But as far as I'm concerned, as I say, I think we're really in the foothills. Whether or not we'll get to understand it a bit more, but it feels like a kind of science fiction thing. If we suddenly understand the brain, will the brain disappear and will the world come to an end or something?
So I totally agree with Gina. Of course, we're just in the foothills. Our best neuroimaging technology is still quite crude. What's interesting, though, as far as this idea of could we replicate a brain and upload it, we might be able to do that maybe 50, 100 years from now, because certainly our computation is on track with that. It's this enormously complex machine under the hood there, but it's all physical stuff, and there's no reason in theory that we shouldn't be able to map it out and find a resolution and then simulate it on a computer. But what's interesting is we might be able to do that before we actually understand how consciousness emerges. But at least that will give us the tools that we want to be able to do experiments by running it in silico.
But the idea would be, if you uploaded somebody's brain into a robot, would that robot be that person? Would, you know, if we put Conan's brain uploaded into a robot, would the robot?
Maybe it's already been done.
Would I get approval of the body of the robot? Would I have any say over?
Yes.
It has not escaped my notice that whenever there's a really intelligent question, it's directed to Gina and David, and then occasionally there's a little scrap for me about what was it like to write for television. So part of my brain that takes offense is on fire.
I've got one last question then. Which is completely off script, so I'm going to get shouted at because we're supposed to finish.
Well, not really. I mean, you're going to get shouted off being completely off script. That was
No,
some
I'm
time
gonna say-
ago now. The idea of script is now a long forgotten myth.
I'm going to ask each of you, and I'll start with Conan.
No, I know what you're going to ask them. This is what's going to happen. You're going to ask our guests, you're going to ask Gina and David really intelligent questions, and then you're going to ask me, do you like potatoes?
I'm going to ask you, given the complexity of this thing that we all possess, to greater or lesser degrees, probably not, do you think that there are going to be many other places across the universe where these things have appeared? I mean, it's kind of off script, but it's just that it seems remarkable to me that this physical construct has emerged essentially spontaneously through evolution by natural selection over 4 billion years, basically out of bits of rock.
Now I want to give my time to the other two that actually know. I was totally bullshitting before I really had no business being on this program.
You didn't literally ask for it. You literally.
I asked for it, and I immediately find myself.
Oh no!
Oh God!
Here he is.
Here he is.
I thought that might happen. For those of you on the radio, Eric Idle's just joined, completely uninvited.
Oh, I'm sorry, I have a quick word for Conan, that's all.
We're live, but carry on.
I just want a quick word for Conan. I mean, I've just got him the gig, and I want 10% of his fee. That's all right. That's all.
I was told it was 20%, but you're welcome. You're welcome to 10% of the massive income I'm going to make for being on the infinite monkey cage. The massive sum.
Yeah. Don't forget it's the BBC.
Yes, the BBC. The BBC is famous world round for just throwing money at any problem.
Shall I answer your question, Brian? I
think Eric should be asked the question first,
Yeah,
and then we'll move on to other professionals.
Well, I see what Gina can answer the question, then David can answer the question, and then you should be able to surmise what the question was, and then your answer. So,
I think my answer would just be a cop-out. In a program that's called the Infinite Monkey Cage, you would absolutely assume that there must be brains out there in the universe somewhere, that somehow the necessary components have come together to make a brain of some kind.
there's a remarkable thing that says, I think it was Richard Feynman, wasn't it? He said that we are collections of atoms that can think. And I think it does seem to me to be a remarkable naturally occurring phenomenon. But David, what's your feeling on the prevalence or otherwise of brains?
I mean, so you pointed out that the Earth's over 4 billion years old, but complex multicellular life is much more recent than that. So it actually hasn't taken that long for us to get here. And the important part is that intelligence has emerged in several places with very different brains. So for example, octopuses are very smart, about as smart as a smart dog. They have a completely different brain structure. It's essentially a mollusk brain. crows are very smart. They have quite different brains than we do. So somehow it's a property that can be found from different angles. And that makes me suspect if we have already in the short time of life on Earth found solutions this many times, almost certainly there's going to be plenty of it in the cosmos.
Erin?
I've something to say, which is probably going to surprise you, but I do believe that one of the things that appeals to me is that we have intelligent life, and it's quicker to evolve intelligent life than to try and get at the speed of light to the edge of the universe. So the only way the universe can communicate in intelligent life is by evolving separate evolutions every 4 million years or billion years or so. And that I think is an interesting thought, that you can actually get from this interesting civilization to another, and another, which will be quicker than trying to reach the edge of the universe.
Very cool.
I think that's a very good take on it, Eric. And with that,
Goodbye.
Eric, you've summarised the entire answer. It's the futility of evolution in many ways, and it's an evolved.
I just want to say to the audience that this was not planned at all. I got an email from Eric during the show, and you may have seen me typing away and said, "Oh, you should just jump in. The engineers will be going completely crazy. How do we mix this? We've not got the right audio track. I apologise."
So I'd just like to apologise to the panel who basically found out that during today's show, what Brian's actually doing is looking up words on Wikipedia and emailing his friends. So if any way he's felt disconnected to your answers,
Right.
there might be a
And inviting other people on.
Yeah, the panel's not going very well. Which one of his showbiz friends can help?
Yeah. We should wrap this up because Lindsay Lohan is joining us any minute now.
All right.
Please welcome Lindsay Lohan and the Osmonds to see about the holographic principle of the universe. Anyway, we also asked the audience a question, and we asked the audience a question: if you could swap brains with someone else, whose would it be and why? And these are the answers that we. There's such great names that people have as well from here, but it was aliens that said the Count from Sesame Street. The chap never gets bored of counting. I would love to have that focus in any area of my life. I can barely even finish a.
Dylan said, "I'd swap with Boris Johnson as mine needs a rest."
Peter Lewis I would swap brains with my partner because for once I would like to know what she actually means when she says it's fine. DBM, I would swap Brian Cox with Brian Blessed to make Monkey Cage louder if slightly less factually watertight. Look at the universe, it's bloody beautiful. Look at it. Look at the stars.
Brilliant.
Thank you very much to all of our guests, to David England, to Gina Rippon, to Conan O'Brien, and he was a little bit late, to be honest, Eric Idle as well. He turned up in the end. It's like actually finally he's watching Waiting for Godot and saying, right at the end, think of the production, and he did turn up.
I just wanted to ask Conan for his reflections on this programme. I hope it wasn't.
Well, I want to say that I understood 2 of the 75 references you people have made. I think I should maybe come and live in England for a few years so that I'm really up to speed next time I come on the show. And but I thoroughly enjoyed it. And I think it's appropriate that we have these brilliant people on to discuss the workings of the human brain, and we ended up solving nothing and really hitting a dead end. I think. Yeah, I think that was very
good. Excellent summary.
Yeah, we've proven that the brain is not very plastic and doesn't function well, and I'm pleased to be part of it.
Anyway, so thank you very much to our guests. Next week is the final episode of this series, and that means you don't have to wear a uniform and you can bring in games. So we're going to be asking, what is life? So that gives you a 7-day Fetmo experiment involving electricity and primordial couplesy.
God did it in 6, didn't he?
God did it in 6 days, I know, but I'm not overly ambitious. I'm giving myself 7. Anyway, so thank you very much everyone for listening, and we will see you for the final episode next time. Bye-bye.
This is
Monkey
Cage.
Any other requests?
No. More of the same.
More of the same?
Yeah, I will need you to look at my 𝕝𝕚𝕬𝕙 at some point.
Sometime tomorrow? Or you want me to do it for me?
If you're focused tomorrow, it could work.
BBC Sounds, music, radio, podcasts.
Hello, I'm Brian Cox.
Yeah.
I'm Robin Ince, and this is the Infinite Monkey Cage. We began the series asking how the universe will end, and we're finishing this series by asking how life began. Basically, what we're doing is we're running the whole thing backwards, so there's a happy ending. And the problem is that, of course, Brian, though, there won't be a happy ending, because he'll then explain that we need to go further back, and eventually we'll return to a time before light and matter, when everything was crushed together at terrible heats.
It's not my fault, is it? It's just the way the universe is.
Physics always spoils everything, doesn't it? It does spoil things, physics.
Today we are following in the footsteps of Erwin Schrödinger and asking the question, which was the title of his influential book, first published in 1944, What is Life?
Joining us to discuss this profound question are 4 separate populations of interacting cells, at least one of which has won the Nobel Prize, and at least one of which we are very certain has not. And they are.
Hello, my name's Ross Noble, and before COVID, I used to be a stand-up comedian, and now I'm simply an amateur chicken farmer who has a lot of chickens who are sick of me doing shows for them. And I think the most intriguing form of life on Earth is anything that can not only survive but chooses to live in Romford.
What a relief, by the way, Ross. We haven't had any letters of complaint this series, so thank you very much.
That's all right.
Final,
The people of Romford,
ensuring that many arrive with an exit
fine.
postmark.
The people of Romford cannot write.
Oh, we're weighing up the mailbag, we're weighing the mailbag.
I think I should get on, don't you? my name's Paul Nurse. I'm a researcher into genetics and cell biology, and today I think the most intriguing form on life is definitely not a chicken, it's a brimstone yellow butterfly, and you'll understand that maybe by the end of the programme.
Hi, my name is Aoife McLeod, and I'm a professor in genetics in Trinity College Dublin, which incidentally is where Erwin Schrödinger delivered those What is Life lectures that the book is based on. And I think the most intriguing form of life is the coronavirus, because it's a tiny little thing at the edge of life, and it has caused a huge disruption to the whole world.
And I'm 𝕫𝕬𝕦𝕙. I come from Romford. I am actually a full-time international model, and I think the most intriguing form of life is a seahorse. And the reason I think they're great, there's 3 reasons. First of all, in the morning they do a little sexy dance for their partner, and my husband's booked that in for tomorrow. I'm sure he's looking forward to it. Also, they don't have many predators, which is always very reassuring to know, isn't it? And also, the male of the species bears the burden of pregnancy, and that's obviously why there's that saying, don't put all your eggs in one seahorse. And
this is our panel. And it was wonderful, by the way, to hear the first barking dog in the background. Every single week we have at least, this never happens at the Radio Theatre. Radio Theatre, one week it turned out it was the astronaut Chris Hadfield's dog as well. That was just as he got to a very pertinent point about life on the planet Earth, his dog entirely disagreed with him. Well, let's start off with the experts. Let's start off with Joe and Ross. So, Ross, the definition of life. How would you define life, as I suppose we've seen it on the planet?
I subscribe to the Keating theory that life is a roller coaster, and you just have to ride it. And it's an interesting scientific theory, because the thing is that a lot of people don't think it's been fully thought through, because does the roller coaster, does that represent existence, and then he hasn't factored in the queue. So it's the queue itself, is that the sperm, and the carriage itself is the egg. But then he hasn't then factored in arriving at the car park and stuff. And his theory was shot down by the foresight theory, and that was that life was the name of the game, and I want to play the game with you. That's what he said. And the chaos of life the chaos of life. He addressed the whole idea of the chaos of it by saying that life can be terribly tame if you don't hold it in. So this is very confusing.
Well, I do feel that we should go straight, because Paul, you have got a Nobel Prize, so if anyone's going to be able to answer the problems of Bruce Forsyth's lyrics, it's probably going to be you.
Maybe, not so sure. I think living things can be defined because they have the ability to evolve by natural selection. That's Darwin's big idea, of course. And to do that, they have to be able to grow, they have to be able to reproduce, they have to have a hereditary system which exhibits variability. And if you put all that together and it all works, you have life.
Now, Joe, do you agree with that or disagree?
I don't know, because I'm from Romford, and I'm not gonna mention it again, Ross, will you please and so everyone else, I'm sure. But I like to try and go down the road of the most simple definition possible. So for me, life is anything that's not dead.
What's interesting, given Paul's definition, Aoife, you said in the introduction that you felt the coronavirus was the most interesting or certainly well-known form of life at the moment. But given Paul's definition, viruses can't reproduce on their own. So are viruses, is it widely accepted that viruses are life forms? I think you said on the edge of life. Those were your words.
Yeah, I think people discuss them in that context a bit, you know, that they are a little, you might consider them a little ambiguous. I don't consider it ambiguous. I think they definitely are life, but they are an utterly scaled back, minimalized form of life. They can't do most of the things. They are parasites. They can't do most of the things they need to replicate by themselves. They must be inside another living cell, which is why lockdown works in theory. You know, the virus can't move around by itself. It can only move around and survive inside people. But I think that also is true of lots of other things. We're not totally self-sufficient either. We need inputs, and the virus needs many, many more inputs than us. But so I would still consider it alive, but I think it's on the edge of that definition. And my definition that I like to use, the simple definition I like to use, since Joe likes simple definitions, is just that life is anything that's capable of self-replicating. So that's not as elegant as Paul's definition. And the problem with
it's also, if it's not as simple as mine, to be honest, I prefer yours.
But the problem with the definition I just gave there is that it would include something like a computer virus, because a computer virus can self-replicate, but we don't really think that's alive, obviously. But that's why the definition is clumsy. So it's simple, but it's clumsy. That's why Paul's is a lot nicer. But yeah, coronavirus, it's just it's the most pared back form of life, I think, that we can consider.
Can I say something about viruses too? Because I've been wrestling with it for over 50 years. I think that was a very nice explanation. I've come to the conclusion that they're both alive and dead. They're alive when they're inside the cell, and they're dead, a chemical substance outside. And I found that sort of satisfying.
Like strawberries for the monkey cage aficionados.
It's also a lovely segue for the fact that your new book, Paul, is initially inspired, is not by 𝕝𝕚𝕧𝕖's series of lectures, which were they at Trinity? I'm trying to think.
Yes.
You didn't listen to Aoife's introduction, did you? Where she actually said explicitly that the lectures were given at Trinity.
He was both listening and not listening.
He was texting.
I'm always in a superposition.
Paul, just because it's topical, Paul, could you just describe how viruses reproduce and just characterise what a virus is?
So a virus, it is fascinating because it is a chemical substance made of nucleic acid, which is the hereditary material, and coated usually in proteins. But it can't do anything unless it infects a cell, as you've already heard. When it gets inside the cell, the RNA, if it's an RNA virus, or the DNA, if it's a DNA virus, is released. And then it's copied, and after it's copied, it produces the proteins that are needed to make more of the DNA and RNA, and also to cover the virus in that protein coat. When the cell gets filled up with all those viruses, then the cell bursts and infects other cells around it, which is why it is the minimalist life form, because it can only work in other life forms, and it's why I say it could be alive and dead, because when it's outside the cell, it's just like a chemical substance. But I think what Iki said was so important. We are all dependent upon other living things, all of us, just to a lesser or greater degree. Viruses to the greatest degree. Actually, these algae, which can photosynthesize, that use light for energy and also for making molecules, are probably the most